On behalf of National Council of Science Museums and Science City, I welcome you all to this popular lecture by Professor Ganguly.
Professor Ganguly, it's a unique opportunity and it's a privilege for me. I think all of you are expectant about what's going to be delivered before you. Professor Ganguly is also the author of more than 250 research papers. He's a fellow of the Indian National Science Academy, Indian Academy of Science, Indian National Academy of Engineering, Indian Institute of Metals, Indian Institute of Ceramics, and Institution of Engineers, India.
If I hit the uranium-235 nucleus, and you should also remember that in nuclear energy, the outer electrons, they do not play any role. It is a nucleus which is only playing any role. And as you know, radioactivity is a spontaneous emission of alpha rays, beta rays, and gamma rays. Gamma rays, normally, they are gamma rays and X-rays, you must remember, they are identical. There is no difference. The only difference is in their source. When an electron comes from a high energy level to a low energy level, it emits gamma rays. When a nucleus comes from a high energy level to a low energy level, it produces gamma rays. So the difference between gamma rays and X-ray is only in the source of their production. So what happens when you hit this uranium-235 nucleus with a neutron, then it splits into two lighter nuclei, and in the process releases about 200 million volt of energy and 3 neutrons. So from one neutron, you generate 3 neutrons. These 3 neutrons will go and hit another U-235, and that's how the fission chain reaction is sustained. Now, if you compare with the heat that is released in the fission process with the classical heat when you burn carbon atom, when you burn one carbon atom, you produce only 2 electron volt of energy. Whereas one fission of U-235, it is producing about 200 million electron volt of energy.